Okay, you want to give it a shot, drawing in the 3 inscribed triangles? I mean, you have the picture here, so when we have 3.
Yeah, I guess you couldn't, it would be hard to figure out a configuration for 2 triangles, or 2 circles in the triangle.
Yeah, that's why he says it's gonna be 1 plus 2 plus 3 plus n.
So.
Yeah, just do your best to draw it, and we'll know all the circles are the same size. Even though it's tricky to draw it on the fly.
So something that looks like this.
Yeah, and all of those circles have the same radius.
Alright. So, what can we do here? Well, I guess the goal would be to try to find one, or maybe try to find this radius here.
Yep.
So, possibly we can do a similar method from before. We can sort of stack the radii on top of each other, since we know, we only know that these connect. This part here would line up just slightly above the radii.
Yeah.
So we can't do it there, so.
Right, so we do have that triangle with
Yeah.
that's formed by the radii. Yeah.
But something else we could try is sort of imagining that we divide here, we sort of chop off this section, and this would be in its own equilateral triangle, and then we know that 3 of the radii stack to, so this length would be 1/3 of the triangle to here. Because this equilateral triangle has this circle as its inscribed circle.
Okay.
So then,
Alright.
with the same principle, you would have the radius as being 1/3 of the this distance here.
That's right. I think the difficulty with that is going to be that when we try to do that we don't know how long this length is.
Yeah.
But yeah, it's an interesting idea. But we have to try to relate the radius of the circles to the side length of the triangle. So that's 1.
1. Well, I guess we know this is a half again to here.
Yep.
And do we know this arbitrary length going up to here. This is the radius.
Right.
Seems like it would be sort of difficult. Then maybe we can try to work with this triangle here. We know that
Okay.
this is 1/2 minus r, because we take this length a half, and then this distance from here to here is r.
Okay.
It's 1/2 minus r. This length is r, and then since this would extend all the way down to here, we know this whole length is √3/2.
Yeah.
And then we have to divide it up so that we can get an expression for this hypotenuse.
Yeah, that's actually, if we can get an expression for that hypotenuse, I think we will be able to solve for r.
see. Well, we know that this is 3r, so that means this is 2r.
Okay, good. So what does that tell you?
That says that, I'll do it over here, 1/2 minus r squared plus r squared equals 2r squared.
That's right. So we could work out that algebra, but there's an even slightly easier way to see what's going on here, besides the Pythagorean theorem, which is a totally fine way to do it. Can you see anything else about that triangle?
Oh, it's a 30, 60, 90 triangle because this bisects this angle here.
Good.
So this is a, so that means r equals root 3 times r, root 3r equals 1/2 minus r.
Yeah.
Okay, so that means we know that root 3 plus 1, or 1 plus root 3 times r equals 1/2,
Yep.
and r equals 1 over 2 plus 2 root 3.
Okay, or we could write it as r equals 1/2 times 1 over root 3 plus 1.
Yeah.
Okay, so maybe we'll just keep track of the radius.
Yeah, that could work as well if we see a pattern in the radius.
Okay, so for n equals 2, we got
Yeah.
1/2 times, am I on camera?
Yep.
1 over root 3 plus 1.
I think the 1 is off camera.
Alright. We'll scoot the camera over.
Alright.
So did we get that right? 1/2 minus r. Okay, good.
Alright.
That's really nice. Alright, so let's see if we can solve it for n circles in general.
Okay.